Hi, welcome to our first lecture of the course, which is an intro to machine learning. So in this video, we will go over some key ideas of what is machine learning, what are the most common problems, and the algorithm typically we use to solve these problems. Okay, so the first thing that we need to know is what is machine learning. So it's a subset of artificial intelligence. AI right now it's big, right? It's very popular. So we have AI here, and machine learning is at the core of AI. It means that what we know of AI right now, such as the large language models like ChatGPT, DeepSeek, Gemini, all of them are powered by machine learning. Okay, so machine learning basically it's the ability of systems to learn from data. Learn from data means that based on some observational data or experiments, uh, our models can use the data to be able to make predictions and to identify patterns, which are the two key goals of machine learning: predictions and pattern identification. Let me tell you that at the core of machine learning, we have neural networks, which are popular models nowadays. And then at the core of neural networks, we have deep learning. These are neural networks with multiple layers. I mention this right now because neural network will be discussed in this course, not right now, but later in the course. And they are really important for today's large language models. It's important to mention this because in the past, neural networks were from open. They were not popular. Actually, they were considered like a dead end in the academia. And researchers that were trying to push neural networks at that time, like 50 years ago, actually they faced problems. Their reputation was affected by doing research on neural networks. But then in 2010, with the computing power and the accessibility to big data, so it was possible to show that they were really useful, and they were beating all other algorithms in different competitions. And nowadays, especially when you're working with challenging data like text, videos, images, for sure you will use neural networks. There are no competitors right there. Okay, so in machine learning, the whole purpose is to create models that are able to learn from data. So there are basically three learning types. There are some more, but these are like the three more important learning types. The first one is supervised learning, and the second one unsupervised learning. So let me give you an idea of what is the difference between supervised and unsupervised learning. So typically, you will have data, right? Different variables. So you have x1 up to xk. Let's give some context. Imagine that we want to predict the price of a house. We want to create a model that's going to be able to predict, like given some features of a house, like the size, location, like if it's old or new, the house, number of rooms, things like that. So these are our features. So based on that feature, you want to predict the price. So that's our dependent variable, right? So if you want to create that model, you need some historical information. You need to provide the model with examples. That means that you need to collect data where you, let's say, in some websites, you will find, okay, this specific house has these features, and then the price is this one. So you collect that data, and once you have that information, you will be able to train the model. Now, what is the meaning of supervised or unsupervised? In this example, if you have multiple houses in your data set, let's say up to n. So you have from x1 to xk, these are our variables, right? Independent variables. And we want to make a prediction of the price. So if you have an output or a target that is clearly identified, and if in your data you have that, in this case, the output is the price of the house, and you have historical data, then that's supervised learning because our data is labeled. That's how we call it. If you know the output variable, if you know the target, if you have the historical information, then your data is labeled. Now, in other problems, we have variables, but we don't have one or more specific variables that we want to predict. There is no clear identified output. If that's the case, then you have unsupervised learning because your data is not labeled. So that typically happens when you're working for a company and you have a data set, let's say with your customers' information, X1, X2, again up to XK. And let's say that these variables are okay, how many items they are purchasing from us, the frequency, and other, like variables related to each of the customers, right? So if we know that information, but again, we don't have like a specific Y variable to predict, but let's say that we want to identify which customers behave in a similar way, so we can kind of like design some specific policies for each, or strategies for each specific segment. Then we can use some unsupervised techniques because we have variables, we have data. Again, we don't have a clear output, but we want to find patterns in our data. We want to see which customers look alike, which customers are different, and why you want to do, and then you want to understand those differences. So that will be an unsupervised problem. Again, because there is no a clear output. Our data is not labeled. So that's the clear distinction between supervised learning and unsupervised learning. The difference is whether your data is labeled. It means if there is one or more dependent variables or outputs that are clearly identifying your data, or if there is no target, if there is no output, that will be unsupervised. So that's the only difference between these two. Reinforcement learning, it's more related to the way in which humans learn. Not just humans, even animals. They learn by experiencing, interacting with the world. We make actions. We get rewards or penalty depending on our actions. Remember when we were kids, maybe your parents were, in the kitchen cooking, and at the time they will tell you, be careful with the, like with the stove. If there is a hot surface, do not touch that hot surface. But of course, we were kids, like we were experimenting, and of course, at some point you touch that hot surface, and you got, some feedback, right? In this case, that was a penalty because it hurt you. So that's reinforcement learning. It's learning from the environment, and when we perform some actions, we get rewards or we get penalties. And of course, the whole idea is that we want to like maximize the rewards and minimize the penalties. So the agent is gonna start learning based on that, feedback from the environment. So that's very common in current models. For example, we are using LLMs. Typically, once you get an output, they will ask you for feedback, like if you liked, the output or not, so they can learn from that. That's kind of like reinforcement. Okay, so this is how it looks, the landscape of machine learning. So you have supervised learning that we just mentioned. Remember, the output, it's identified. You have one or more dependent variable that you want to predict, right? Or that are part of your interest. Now, inside supervised learning, there are a lot of problems, but the two biggest problems for sure are regression problems and classification problems. So what's the difference between regression and classification? I will show it to you through the video, but let me quickly mention that in a regression problem, the variable that you want to predict, the Y variable, is numerical. That's the important thing, it's numerical. For example, in the housing model, remember, we want to predict the price of the house. So the price is a numerical variable, right? Then if the output is numerical, that's a regression problem right there. It can be continuous, discrete, I will show you that later. But in this example, if you notice, the weather forecasting, that's a numerical variable. Life expectancy, that's a numerical variable, right? Population growth, that's a numerical variable. Now, in the case of classification, our output, our target variable, our dependent variable is categorical, it's not numerical. So here we will use classification problems in healthcare when you want to predict a disease, whether a person has a disease or not. In agriculture, same idea. If you're analyzing, plants and checking for specific disease, you can create a classification model that will predict whether that plant will have that or not that specific disease. So the output in those models, it's categorical. It's like it has the disease or it doesn't have the disease. Now, it's not binary always. It can be like multi-class, multi-class, like with multiple classes. Let's say that you're predicting the quality of a product, so the output can be like low quality, medium quality, high quality. So that's possible. But again, the main difference between classification problems and regression problems, it's the output variable, whether it's categorical or if it's numerical. In unsupervised learning, there are different problems again here, but the two most common problems are the clustering for sure. Clustering analysis is when you want to group your observations, find similarities or differences. In the customer segmentation problem that I mentioned in previous slides, that's an example of clustering. You don't have a Y variable, but you have some X variables, so you can identify which customers are similar in the way in which they behave, right? So there are other unsupervised techniques here from interesting problems, the recommender systems. Every time you use, like YouTube, Netflix, once you watch a video, you get some recommendations. That's a recommender system right there. Dimensionality reduction, that's very important in machine learning, especially when you have, like a high dimensional problems. It means that when you have, let's say, a lot of columns in your data, a lot of variables involved in your problem. I'm talking about like hundreds of thousands, even millions of variables. So if that happens, then sometimes you want to reduce the complexity of your problem. So the dimensionality reduction techniques help you to reduce, the number of variables. So there are different algorithms that will help you do that. Just to mention a couple of them, principal component analysis, PCA, which we will cover in this course. It's an example of dimensionality reduction and helps you again to reduce the complexity of the original problem. Reinforcement learning, we already mentioned this type of learning, and it's used in games, also in real-time decisions. And now with the, like the cars that are driving, self-driving cars, they use these technologies for sure. There are other problems that I didn't add here, but that are really important. In supervised learning, for example, we have time series analysis. Time series is critical. It's really important, time series. Think about stock markets. You want to predict, like the price of the stocks, cryptocurrencies, and for companies, it's a common problem is to predict the sales of the next month, next week. So that's time series analysis because you want to understand how one variable behaves, in this case, the sales or the demand for a specific product or service, and then you want to make predictions, right? So time series is a supervised learning problem. It's really important too. Okay, I mentioned that in the previous slide. I'm just gonna give a little bit more of details now. In the supervised learning, where we know our target, is not always one. Let me be clear with this. It's not just one target. It's possible that you want to make a prediction of multiple variables. You can have two or more. That's possible. But most of the problems that we will cover initially, they have a single output, right, or single target. So when we have that, so we're talking about supervised learning, and again, we have classification and regression. The difference in regression, the output or the dependent variable is numerical. In classification is categorical. So that's why you see here in the example, in the regression, which is a numerical variable, your model, you want to fit the data. So you want to minimize the error, or the error will be the distance between each observation to the line, to the prediction. You want to minimize that. Typically the sum of square of the errors, right? You want to minimize that in the regression. In the case of the classification, you want to separate, you want to classify, right? So in this plot, you have two categories. Let's say that these are like healthy patients or the patient with a disease. So you want to find a model that is able to classify them. So here you want to fit, like the observation, you want to separate them. You want to be able to identify how to differentiate the classes, right? So the idea, it's different. In the regression problem, it's important to mention something. I'm sure that most of you that are watching this video, at some point during your undergrad studies, I'm sure that you have studied the linear regression model. So the linear regression model is an algorithm. It's an algorithm. It's a way to solve the problem. It's not the problem. The problem is the regression problem, right? You want to make a prediction of one numerical variable. And there are different algorithms that will help you to solve that regression problem. So linear regression is just one of them. Of course, there are more than just the linear regression. You also have regression trees, random forests, XGBoost, neural networks, just to mention some of them. But there are different alternatives here. Now, of course, in this course, we will go over different algorithms to solve the regression problem. There are a lot of examples of regression problems where you want to predict one specific variable. For demand forecasting, if you want to predict the amount of fruit or vegetable that you are going to get in a specific farm, that's a prediction model too. And if you want to predict, let's say, the life expectancy of a patient based on different features such as the age or vitals of the patient, so that's an example of regression. There are multiple ways in where you can use this type of models. In the case of classification, our variable is categorical, so you can have binary classification where there are two classes, or multi-class where you have three or more. Similar as in the regression problem, here we might have multiple algorithms to solve the classification problem. So the most popular one will be the logistic regression, but then you have also regression tree, classification trees, random forest for classification, support vector machine, and even neural networks too. So typically you will find that the most common algorithms, they have two versions, one for classification and one for regression. Now, in the case of unsupervised learning, remember here we have unlabeled data, so there is no output clearly identified. So we have clustering and dimensionality reduction. So in this course, we will go over different clustering algorithms, such as k-means, DB-scan, hierarchical clustering, just to mention some of them. Dimensionality reduction techniques, we will use PCA for sure, and a couple of more algorithms. So in the case of clustering, this is how it looks. So initially we have here two variables, let's say x1 and x2. You can visualize the data, and of course you will see that with three groups you can cluster your data. So the technique will identify those clusters. Typically it's not that easy here because we can visualize the observation because there are only two variables. But in real life, you will face problems with hundreds of variables, and so you won't be able to visualize, the clusters like this. You will need to, to try different values to see, or different parameters of your algorithms to be able to identify which is the right number of groups and cluster your data. The reinforcement learning. Again, this is learning through trial and error. So the agent or the individual is going to perform some actions, and given those actions, they will get a reward or a penalty. And there are some objective functions, one or multiple objective functions that you want to maximize or minimize. So the agent is going to perform the actions trying to optimize those objective functions. The popular algorithm here is Q-learning. So in regression, linear regression is like the basics, like the most common algorithm, not the best, but it's very popular. In the case of classification problems, logistic regression, it's the most popular algorithm. Again, not the best, but it's very popular. In the case of reinforcement learning, Q-learning, it's the most popular algorithm. In clustering, K-means is the most popular algorithm. Okay, so how's the typical machine learning workflow? Well, the first step, it's always to look at the big picture and understand what is the problem, the business problem that you're facing. So what do you want to predict? What do you want to understand? Which pattern do you want to identify? So once that's clearly defined, so we need to get the data. So in the course, most of our examples, the data it's already in a table. But typically, you will need like to perform some experiments, or you will need to combine data from multiple sources. So it's not that simple. You will need also to clean your data, prepare it. It is important to explore and visualize the data. So this is what we call the EDA, the exploratory data analysis, which is a key step in any machine learning analysis that you are performing. Then we prepare the data, we train our models. When we say train, it means that we estimate the parameters of the model. If it's a linear regression, so you just compute some betas, right? We will see that in our next video. But if you are using trees, you need to find, like the different values to make all the separation and to do the splits on your tree. So once we identify the best model, like the best performing model in our data, we fine tune the model. It means that we compute like the best hyperparameters. And of course, we present the solution, we validate the solution to see whether it makes sense or not. And we need to test it, of course, before we deploy it, or that's what we call the model is in production. The production stage means that the users are using the model on a daily basis. And of course, we need to monitor the performance of the model, maintain the system, because data, it's possible that there are some changes in the data. The data that you use for the training at some point might change in real life. That's what happened. That's normal, because there are changes in the economy, there are changes in our environment that may affect the distribution of our data. So we need to ensure that we monitor the behavior or the performance of the model, so we can adjust if it's needed, right? So this is how it looks. The complete pipeline. So we have our data from multiple sources. We explore and we validate the data. We clean our data. Before we train the model, it's important to split. This is a key concept in machine learning, which we will cover in future videos, cross-validation. It's always important to split your data. You don't use the complete data set to train the model. What we do is that we split it into at least one part to train the data and the other one to test the performance in unseen data. So we perform all the model engineering, that's the training, the evaluation, and of course, when we get the best possible model, then we need to deploy that model so the users can start implementing the model, and we need to monitor, and of course, using the feedback from the metrics that we're using, we need, in some cases, to perform some adjustments. Okay, so to conclude this video, it's important to mention that machine learning, first, it helps us to make predictions, to identify patterns, and basically to learn from data. That's the key idea. It's the core of artificial intelligence, especially neural networks, like deep learning. It's like it's powering LLMs right now. I'm talking about 2025. So yeah, they are, for now, these are our like more powerful algorithms to be able to solve challenging problems in machine learning. It's important for us to know what are the different learning types, and of course the different problems. Is people when we're learning machine learning, everyone focuses on the coding part, and it's important, of course, the code. But nowadays with generative AI, the code it's easy to get. So what matters at this point is that you have a clear framework, that you understand each problem, and that you will be able to recognize those problems in real life. That's what really matters. Like that, okay, I'm facing this problem, I can use this specific type of model to solve that problem. And then, of course, the model assessment to understand whether that model is behaving in the right way, so you can use it to make decisions on a daily basis. And of course, data quality is really important. It's not just the algorithm choice. Sometimes You might have a very complex algorithm, like a really neat code, a very complex algorithm with a lot of parameters. But if the data quality is not there, then the performance will not improve. So it's a mix here. We need good data quality, and of course, we need to use the right algorithm to solve the problem. Okay, I'm gonna stop the video for now. I'll see you in the next lesson.